Hello and welcome to all students in this our today's lecture. Students, we are in the topic of chemical kinetics, and in our today's lecture we are going to look at the initial rate method. In initial rate method, this method involves the determination of the order of each reactant separately. Means suppose if we have a reaction A plus B gives C, and in this case if you want to determine the order of a particular reactant A or particular reactant B, we can determine its corresponding order separately. This is what we will look at in the initial rate method. To determine the order of a particular reactant, its concentration is varied keeping the concentration of other reactants constant. Now this is very important concept for the determination of a particular rate of particular reactant. In every experiment we determine the initial rate of the reaction and observe the dependence of rate on that particular reactant. Suppose if we considered a reaction A plus B gives C, for that the rate is directly proportional to its corresponding concentration, and the terms m and n indicates their corresponding coefficients which are used in the particular reaction. Now students, keeping B constant means, suppose if you want to determine the rate for reactant species A, at that time according to the previous statement we should keep the concentration of B constant, and for A we are going to determine its corresponding rate. Now some examples may be asked in your exam like this. The pattern of questions, that the problems will be like this. Rate of the reaction A plus B gives product is given below as a function of a initial concentration of A and B. Look at this table. You will notice here concentration of A in mole per liter and concentration of B in mole per liter we have mentioned, and the corresponding rate for their corresponding concentration of A and B species will be mentioned in the third column. Now in that case what we have to do is determine the order of a reaction with respect to A and B. Now look at students, we will solve this question. At very first what you have to do is, for first two experiments the concentration of the reactant B is constant. You just go into the table, you will notice here concentration of B is constant and the rate of the reaction depends linearly on reactant A. So this is the main logic behind this that you have to apply for solving such a problems. Now taking experiments first and third, the concentration of the reactant A is constant. Look at in table, you will notice here. Now what you have to do is, taking the experiments first and third, now look at the observation table that they have provided to you. The concentration of the reactant A is constant. Therefore, the rate of the reaction is independent of B. This is the conclusion that we can conclude from the above table. And at the last, we can say that the order of a reaction with respect to A is 1. So this is the logic behind the solving such problems. Now order of the reaction with respect to B is now to be will be 0. So you just by observing this table we can solve such a types of problems, and this type of problems may be asked in your exam like the competitive exams in CET, JEE, or sometimes in NEET also this type of questions may be asked. Now students, we will learn the half-life method and their corresponding graphical representations. Students, we have already determined the half-life time and t 1 half will be directly proportional, inversely proportional to the concentration of that corresponding species. If a reaction will be an elementary reaction, then its concentration we will mention like this. For zero order, first order and second order, comparatively we have studied the half lives versus concentration. So the plots we are getting will be like this. For zero order, graph, nature of graph will be straight line passing through origin. You will get the positive slope here, but for the first order you will notice here the if you look at the time, that is t 1 half, we have plotted versus its concentration, you will get the constant nature of graph. And if you look at the third graph for the second order, you will get some intercept on the y axis, and also you will get the slope positive. So this is the half life method. And students, some problems may be asked in your exam. Half life of a, like this, the half life of a particular chemical reaction at two different initial concentrations, they may be given in your examination. That the values sometimes may be provided in a bracket also. 5 into 10 raised to minus 4 and 25 into 10 raised to minus 5 molar are 2 and 16 hours. In that case, what you have to do is calculate the order of a reaction. Now students, we will find some solution for it. First of all, you have to write its corresponding t 1 half equation. If you once you have calculated the t 1 half equation for it, then you have to use it for the calculation of half life of a particular chemical reaction. And once the formula that you have taken, in that you have to just put out all the values as they are given, so you will get the particular answer for it after solving. And the power which we have used is nothing but the n minus 1 here in the in this problem. So if we rearrange these terms at the end, you will get the answer for n, and that n will be nothing but this is the order of the particular reaction. And in this problem, what we did, we have taken the value that we will convert 8 2 raised to 3. The answer will become as a n minus 1 is equal to 3. So we have rearranged that equation in that term, and we have finded the value for n is equal to 4. This is nothing but the order of the particular that reaction. Now students, integrated method. In this method, we put the data into the integrated form of the rate laws and calculate the values of the rate constant for different kinetics of the reaction. Now the order of the reaction is that one of which the values of rate constant will be constant. Now some first order reactions now we are going to look will be decomposition of hydrogen peroxide, and the particular reaction for it you will get like this. Decomposition, after decomposition it will converts into corresponding water, and O2 gas will be liberated. Now students, let V0 and Vt will be the volume of KMnO4 used during the 0 and time t respectively. So for that we can construct equation for first order rate will be like this. Rate constant K is equal to, at very first we can say that a rate will be directly proportional to the concentration of that species. After time t it will becomes A minus x, and if you want to determine the K for the above equation, you will notice here for the first order you have to take the equation like this: 2.303 divided by t log to the base 10 of once we have taken the value of 2.303, at that time you have to take the value as a base of log to the base 10. So the concentration of that particular species at 0 concentration and at time t will be like this. Now students, some first order reactions, some of the examples that we have taken here, in which hydrolysis of ester is a good example. Hydrolysis of ester is done at in that particular reaction you will get the corresponding acetic acid as well as ethanol. But if you look at its corresponding initial and at time t, you will notice here at the start the concentration of the particular species, that is ester, will be 100%. At that time the product which in which the acetic acid and the ethanol get formed will be 0, and after time t you will notice here the term A will becomes A minus X, means somehow reactant concentration will be converted into the product. So that term X, what it indicates, the fraction of the reactant which is converted into the product, and that at this at that time the same amount of product you will get here. So we have denoted as a XX at the acetic acid and ethanol, and after the end of that reaction, if we concentrate on the values of that corresponding reactant species and the product species, you will notice the opposite to that of the first. Means now here reactant concentration becomes 0 and the product concentration becomes maximum, that is 50-50. Now let V0 and V0 Vt and V infinity be the volume of the alkali required for the titration during 0 time and at infinite time. So here V0 is the initial volume which is required, which is directly proportional to the corresponding hydrochloric acid, and at time t HCl plus X, and at the infinity you will get the HCl plus A. In your textbook somehow different notations have been used, so you just get the meaning like that of the you just go on following your textbook notations, or sometimes you can also refer the other books, then you will get the, or you can find the different notations for it. And here V infinity minus Vt will be directly proportional to the now A minus X, means the fraction of the molecules which are remained at time t, and after the end of reaction you just go on finding the volume at infinity. It will be directly proportional to the species or the concentration of that particular species. And if you want to find the K for it, that is rate constant for that particular reaction, you will get the formula will be like this: V infinity minus V0. So you will get the corresponding value for it. In the problems sometimes directly the values for V infinity minus V0 will be given, and sometimes you have to just calculate by looking at the reactions, and sometimes Vt also they have provided with the problem. Now students, theories for chemical kinetics. In that case, now we are going to look at the collision theory in our next lecture. So this is all about in our today's lecture. Thank you very much.